Hi, I'm Eduardo. I work for a company called Sendo, which is more known in Australia than in New Zealand. Um, it's a company that works with delivery for small businesses, and we use a lot of Elixir and Ruby. And today I'm here to talk about Ecto.Multi, which is basically a way for you to compose transactions, database transactions using Ecto. Cool. So I hope that I can cover all of this. So what's Ecto? How do we build transactions? What is actually Ecto.Multi? How you write tests, and what happens when you're gonna mix and match non-DB operations. So first, I will talk about what is Ecto. So Ecto is basically a toolkit to map data. It doesn't necessarily need to have any database, as in the SQL database or whatever database. I'd like to call Ecto basically is structs on crack. So if you ever used Elixir, or if you've never used Elixir, here's what is a struct is. This is not Ecto, by the way. Basically, for example, here a sign up is a named map, and a map is just a key and a value. And you can have, that's all you have. You can have with structs more or less. You can have what are the keys that you have. So name, age, email, and accepts conditions. You may have a default value, but that's not much. So for example, name will accept anything and it will not complain about anything. And you basically cannot declare a lot more than this. And Ecto has a way for you to declare almost like a super powerful struct. So in this case here, also no database here. It's basically memory stuff. I'm now declaring the same struct, but now using Ecto. And here I can declare what are the types and stuff like this, which can then be used by Ecto to, for example, cast or translate stuff later on. Also, it helps when we actually need to do queries and inserts and whatever, and it knows how to map them to the database. So here's a classic example of a weather table where you can declare, hey, I have a weather table, here are my fields, and there's actually a default value here somewhere. But then what I'm here to talk about is about transactions. So in this case here, I will use this example for the rest of these two tables for the rest of my presentation. You have the concept of transfers and accounts. We're going to build a bank here, a very basic bank that you can have accounts. The accounts have names and a balance. So and this balance is an integer. Let's say it's in cents, just so we simplify everything. And the transfers are basically the registrations of the ledger saying, hey, this user sent, this account sent this amount of money to this other account, and you can keep the balance. That's basically it. And when you have a bank, you probably want to, when you remove data from money from a balance from an account and add to another one, you want them to happen at the same time. Because imagine you go, okay, I'm gonna reduce here this from $100 to $20, and then okay, now I'm going to update the other accounts to actually get this money that just got removed. And let's say that something happens and you never updated that, you get one account that lost money and an account that never got any money. So you probably want them to happen at the same time. And here's more or less how you could write this using vanilla Ecto with no multi. So basically here I'm receiving an account ID and from account ID to an account ID. And I'm basically building this big transaction here where on this with, you have, I want to update the from account to remove this amount. I want then to update the to account to increment this amount. And also I want to insert the transfer to register that that transfer happened at the same time. If everything goes fine with all these statements, then we return okay because everything went well. If something went wrong, for example, a constraint, let's say that I have a constraint that the balance cannot be negative, for example, or something else like a unique value on my database that I will just find out that it's not unique or it's unique. when I try to insert or update. Then you get to this else part, which is if, so those 1 and underscore means that 1 row was updated. So if I get that no row was updated, it means that something went wrong, so I want to roll back. Or actually, if any error went wrong, I want to roll back. So as you can see, at least I hope you can see that it's not super trivial to understand what's going on. And the more things you add to this, more complicated it becomes, because you have to treat all the cases where it fails. We don't know exactly what failed, for example, on this 0 underscore. We don't know exactly which of the operations failed. So you could find out which one failed, but it gets more complicated because you have to be very specific on how you treat those operations. And this is how you would write using Ecto.Multi. Multi, so I think Ecto is probably the best library that exists in Elixir. If I had to pick one, probably the most well documented, and I've never found an actual bug that caused a lot of issues with Ecto, and it's mostly perfect library. And I would say that Ecto.Multi is probably my favorite part of Ecto. So here we are building the same transaction that we built on the last slide, but now using Ecto.Multi. As you can see, I'm just using an alias here to not repeat Ecto.Multi, but it's multi. So I create one, then pass to call that update all, doing basically the same thing. And I'm giving names. So the second argument, so the first argument is always the multi, the actual initial multi struct. Second argument is the name. So I'm giving a name called from, then I'm going to give a name to, I could have called from update or to updates to be more specific, but my slide was getting big, so I just used from and to. And then at the end, I want to insert a transfer. So I'm going to go back here just so we can compare. So we had 2 update alls and then an insert. As you can see, you can almost copy and paste and then change it. So this code is not exactly the same thing that happened before, because here I'm not applying the transaction, I'm just building the transfer multi. And that's where I wanted to show how you can compose stuff. So as you can see, I'm just getting something, passing to the update all. That multi update all will return another multi. And I can keep doing this. Basically, I'm stacking operations, and they will operate on this exact order that I'm doing. So if I switch the order, it will actually change the result, or may change the result depending on what you're doing. It's very generic because, as you can see, and if you look at the docs, every operation with multi, I'm not going to say every, but it's probably every, will receive a multi, and then you have the name of the operation, and then what it actually do. There are some exceptions, like you can merge multis. If you grab a multi from somewhere and you want to combine these operations so they have the same time, you can do it. Slightly different, but it's mostly like this. And it's introspectable. I'll show how introspectable it is soon. So to get the actual result, you need to do something like this. So you call transfer multi, here are the IDs 1 and 2, and I want to move $10 from the account 1 to the account 2. Then I pass to the repo transaction. So that same place where I sent, where I use repo transaction and sent a bunch of things happening, that's basically how repo.transaction works. So this is basically saying to the database, hey, here are a list of operations, execute them in this specific order. And this is the result. So the result will be, we will have the keys as the names of the operations. So as you can see here, from, to, and transfer. So from, it said it updated 1 row. It says new here on the second value because I've never asked to get anything back from the update all. But if you say update all and return me the tuple or the row, it will actually get you back the account, for example, in this case. Then 2 also worked, 1L. And then transfer, I got an actual bank transfer, which is that overpowered struct that is powered by Ecto. And as you can see, it's all working. One other cool thing is that you not just get the actual result when it works, but you get the result when it fails. So for example, let's say that I had another type of operation happening here. If it's successful, I get my account, log, sessions, whatever. But if it failed, my error will actually be, hey, which operation failed? So if you had 100, you can send as many transactions, not as many, but you can send a lot of operations in a single transaction. Let's say you had 100, it will actually say, cool, this one, which happened on the, maybe the last one, here's the one that actually happened. It will get what is the failed value that I got back from the database and all the changes that would applied so far. So you can know, for example, oh, I know that the second and third operation worked, but this one didn't work. I want to do something else. So all of this is possible with Ecto.Multi. Most of the time you don't want or you don't need this because a lot of the times you want to apply something and something went wrong, do something else. You don't really care which operations, but it's possible and it's not hard to find this information. It will just give you exactly the which operation caused the failure to happen. And then here to show how easy it is to introspect. So here's a very simple test case on how to write tests for this. So I have Jose and Eric here, and I want to do a transfer. So I'm calling this function here called Ecto.Multi toList, which basically transforms the multi that we built in a list of operations. So I'm then doing an assertion and saying, hey, I want to check that multi from looks more or less like this, multi to looks more or less like this, and my insert will be a change set, which is also a term of what is a change in Ecto. And it we'll have a data, and the data will be a transfer, and I can say that I want to assert that the transfer is like this. So I can do a lot of things. Not everything is introspectable because Ecto queries, for example, are not that easy to introspect. I don't think they even have an option for you to inspect stuff, but at least the operations you can. So in this case here, the operation never ran. I never had to actually go to the database to execute it. So for example, if you want to just do a very quick unit test to see if things look okay, you can do it. You can have another actual integration test that runs to the database, applying the actual changes if you want to. But for example, in this case here, we can just take a look and see what operations we would apply if it actually ran. And one thing that it doesn't need to happen, but you can, is you don't necessarily need to do just database operations with Ecto.Multi, which means that you can do something that is not related to a database operation with things that are coming from the database operations. For example, a very common use case from every system out there. I want to send an email after some DB operations happened. Or I want to send an HTTP request to some API and then perform some operations. So here's a classic example. I updated the account. So same example, I updated the accounts, registered the transfer, and then I want to send an email to say, hey, this transfer happened. I hope you know that this is actually happening and you actually created this transfer and no one invaded your account. So in this case, two things that I want to show. One is that multi-run, you can have when you execute multi-run, you can actually receive the changes so far. This is valid for other things I'll show later, but basically multi-run is generic way of saying, hey, given all that happened so far, in this case, I want to pick the transfer, but I could pick the from and to. They will all be available in the second argument of the function. I want to go, hey, given the transfer that happened, I want to send an email called the function send email with the transfer. This is a way to do it. Let's say this use SMTP, or it's an HTTP request to, I don't know, some API that sends emails. You probably do not want to do it right now at this point in time for a few reasons. So when you're doing a DB operation with, for example, pick Postgres as an example, when it's actually executing, it will go, hey, I want to begin a transaction. I want to update, then insert, and then the transaction is still running. So the database is waiting there on that connection. So you picked a connection from Ecto, started sending things, and then you stop. You send the email. Let's say it takes 10 seconds. And then you commit the transaction. There is a chance that this transaction will fail because your database may have already received other transactions and other things. Other thing that could happen, your connection got dropped or it timed out. Also, you introduce possible errors to your connection, they are not necessary. So this is one of the things I would say that you shouldn't do, or you should have tried to avoid. Multi-run is still used for other things. So for example, if send email was actually a bunch of other DB operations with something that you don't even know what it is, it would still be part of the transaction, and you don't even need to know if it runs. The function that is being called, that doesn't even need to know that it's running inside a transaction. But and then that's when things that could be used to help with this is using some job queue that runs on top of Postgres. So there's these two projects, Ecto.Job and Oban. I think it's called Oban. I think that's how I pronounce it. Ecto.Job was actually created by Mike, who just presented. I'm pretty sure he created it, but it's on his name, so I'll say that he didn't buy it, so he probably created it. And the funny thing is that I didn't even try to do it. These are the two examples on their readmes, sending emails. So instead of actually sending an email, you would probably go there and actually insert a job saying, hey, I want to send an email later on, and then this would be done. So you do update the transaction. Well, here's a slide. So I would go to this one. So instead of doing that run to send an email, we would actually create a job. And in this case, I'm using an insert with a function instead of just passing the actual job, because I want to get the result of transfer. So I'm doing, hey, I want to insert, and here's my new job that is based on that transfer. So when it runs, it will insert this into Postgres, Ecto.Job, or if you use Noban or any other job queue sort of system, it will eventually pick up that job and it will execute it. The good thing is that you get all the nice things of it was a single transaction, so you never have two jobs asking to send an email. One thing that it will not protect you, and nothing will protect you, is if your email provider does not have a way for you to send a unique ID and say, hey, here's a unique ID for this email. If I send it again, just ignore. That's something that you have to find with your provider. If you look on APIs like from Stripe and these Shopify and whatever, you find that most of them support ways for you to do things that if you try to do the same thing over and over, it will just be a no operation. So hopefully that's the case for your email service. One important thing is that one cool thing is that what happens here, for example, using Ecto.Job, is that the first argument of your perform function that will actually execute the job is an Ecto.Multi that has already the operation to delete that same job. So as soon as it will run, let's say you have another thing here, for example, in this example from the README, it's inserting some stats around the actual send stats, and then we'll commit the transaction. When it does this, it will also delete the job. So you get also a nice and clean single transaction doing everything. And here's an example with the request instead of an email. Ideally, you want to do the request first if possible. So if it's possible, so let's say you could here go multi.new and then do a multi-run that actually sends the request, but you don't get a lot from this because you may start a transaction to then just go and talk to an API and come back to the database. So probably what you want to do here is send a request. Hopefully it's a request that you can repeat if need be, and it's unique. It's not going to generate more things for you. And then it will call update all in certain transactions. So ideally, if you need to do something that is between operations, ideally you'll probably want to put this in a job that is backed by Postgres or whatever database, SQL database you're using. And if you can do something before you actually run the transaction, it's probably also a good idea. I did this, it doesn't look great, but here's an example, a generic example. So imagine blue is a DB operation and red is an API or external, something that will talk to something that is not your database. Imagine this was a single piece of code that would go DB operation, call an API, DB operation, call an API, DB operation. If you ran this in a single transaction, it may take a lot of time. A lot of things could go wrong. Your APIs, you don't have a lot. If it's an external API, you don't have control over it. So it could be down or it could be super slow. So what you probably want to do is something like this. map these two first in a transaction that enqueues a job, that does the second part, that enqueues a job and does the third part, so they can all retry safely. And if they execute cleanly, you don't have a lot of repetition of transactions, and they usually are much easier to understand what's going on if something goes wrong. And one thing that I want to say is that most of the examples that I've shown here are based or literally copied from the little Ecto book that is curated by the Dashbit company, which was called Platform Tech before. Or it got out of Platform Tech, and it's where Joseph Valim is working. And they basically maintain Ecto, Broadway, Elixir. This little Ecto cookbook has a bunch of really interesting topics about Ecto, including Ecto.Multi and gotchas on some areas. I think it talks about CTEs. It's mostly like a, hey, you already read Ecto, you know the basics. If you want to know more and some gotchas and some stuff that can be more complicated, go there. It's actually pretty little. I think you can read in 1 hour, and even like actually running the examples. You can just go on Dashbit's website. I think you can if you put your email, you get the ebook on your email. And by the way, we are hiring. So if you're looking, we're looking. Software engineers out there. If you liked what I just talked about, we do a lot of this stuff at Sendo. And yeah, if anyone has any questions.
Awesome. Thanks, Eduardo. So yeah, if anyone's got any questions, feel free to unmute yourself.
Hi, Eduardo. Rob here. In your just the plain Ecto example, part of the reason, I guess, that it expands onto more lines is because you're doing some error checking there on those update alls, and you're not doing that in the multi version. How would you incorporate that? Yeah, so in the with clause there, you're not sort of doing the checking that your update just updated one row. Yeah, so in the multi world, how do you do that, or do you need to do that? Is there something subtle that I'm missing there?
No, so that's a good point. So here, I'm actually not checking the result of update all, but if you wanted, for example, here on every operation you do, instead of passing just the actual update, you can pass a function that receives the previous result. So you could check that from is actually one and something else. Yeah.
Okay, cool.
Yeah, so I think the example that shows this is here. Basically, like almost every function that I'm using, like insert, update all, run, they will receive that you can receive the changes so far. So you could do from was one something and to was one something, etc.
Right. Yep. Gotcha. Yep. Cool. Thanks.
Cool. Good question.